Great. Hi, everyone. So yes, standards. We've heard a little bit about standards today. Andreas said possibly it's where people will never get seen again. There's no returning from it. But there's many good reasons to enter it, I think, as a career to drive a lot of things forward. And I think perception has changed greatly during the time of this Etrix project. Like in 5 years, I've seen a lot of support for standards and a lot of people understanding the benefits. So today I just want to give you an overview of where we're going. We'll just go through. Yeah, fine. So looking forward, next 5 to 10 years, the sort of changes we'll see. Just want to go through. This is what I'm going to do a general run through of my slides today. Looking at the top one here, roadmap for semantic interoperability. There's a big word, a big concept. I want to talk about how far away we are from that and how we get there, and the sort of initiatives that are being undertaken right now. Increasing data sharing, something you're all hearing a lot about. I've got a couple of examples about this, but some real world evidence of where it's being used and the real benefits that people are getting from it, the lives it's saving, etc. And then I want to talk about convergence and advancement with standards. Convergence is, again, another big word with lofty ambitions and reality, often lagging behind those aspirations. And then a little bit beyond 10 years, and I think that there's a lot of people in this room that have been doing it longer than I have, a lot of people with more qualifications than myself. We can talk about what we see is going to aid standards in the future, where we need to go, how we need to work together and collaborate better to really make sure that they're much more implementable and more broadly used. And so modernization takes time. There's a lot behind this slide. I think really the important thing is talking about systems and updating those systems. The standard is a prescription, but it's a very complicated prescription that has to be implemented, and systems within pharma are very complex. They're distributed between global systems, and often those countries within those pharma companies aren't always integrating their systems through a lot of mergers that are happening. So the integration of a consistent set of standards is a very big problem. But a lot of this is being fixed, but we're always lagging behind the sort of standards see this right. So our ambitions at see this are always sort of following, they're ahead of the curve, while the people from pharma are sitting on our organisations, our working teams to tell us what they want to see. Things like therapeutic area standards don't get implemented probably from 5 to 10 years, and some ambitions within pharma maybe lag behind that as an achievable milestone. So that is a real problem. Looking at the roadmap, and this is a slide I borrowed from the Yosemite Manifesto. I think it was a very nice highlight of where we're going now, and the sort of technologies that are really going to help us. You'll see at the bottom left here, the talk of RDF, a lot of work being done in RDF because it shows the sort of relationships between the variables within our standards, and it's a nice way of then being able to implement an electronic version of a standard. See, this has moved very much towards electronic versions of standards. We used to have PDF, and that's very difficult to implement. And historically, a lot of the problems were the wiggle room between the standard written in paper and what pharma's interpretation of that is. So we've now moved towards metadata registries where we're building those standards in and then giving people back an electronic version of that standard with the relationships now using RDF, which is a nice new XML technology, fairly new anyway, that's getting a great uptake. It's also mandated by the Yosemite Manifesto, which is creating a little bit of support for this. So moving along up towards semantic interoperability, I talked that 20 years, maybe 90% of all data would be interoperable. Andreas talked about the academics and that being a real big problem. But that might take 10 years before they really get on board, and then maybe another 20 years from that date. So they're pie in the sky figures, but it really shows that only in 5 years, if we were to get between, say, 10 and 30%, we'd be doing rather well. But at the moment, the interoperability of data, it's more of a concept than a reality. But I'll walk you through some of our slides and we'll show you what we're doing to see this, that is making this a fast reality. So in between this, we're looking at ontologies, and I'll talk today about what CDISC is doing with their ontologies, some of the issues with that and how we're trying to fix that. There's a note there on IDMP, and I'll talk very briefly about us integrating with other external, more global vocabularies. And we heard a little bit about FHIR. FHIR, we have an ODM2, which will do, it'll be a similar interpretation of FHIR, much more usable technologies for data sharing, for integration of control vocabularies, and it'll be much more lightweight than the current ODM version. It'll be using things such as RESTful APIs, JSON as well. So this convergence of technology is a really important part of this. While HL7 are doing one thing, we're doing the other. There's many other players in the market that are doing slightly different things, but we are converging, and we're all getting on the same page in the future. So I think that's very exciting. That will be a real enabler in the future to pass things like electronic health record data through to an actual clinical trial. On the other side here, the other enabler is the translations of this and making sure that terminology can be global and how to incentivize people to get involved in doing that. There's not enough of that at this stage. I think it's looked at as an expense. Most things are done in English. That really isn't the way forward. I think if you want to make things usable within different countries, I think translations is really important. So increased data sharing. I think this is really showing. I'll talk very briefly about this because we've already seen Ryan Hart talk about it. So it's obviously, it's in the press. This was taken, I think, from The Economist last week, and they're talking about the value of data. But I think that is important to go on and talk about how you get the value out of data and how you make data valuable. And data is unlike oil, as Ryan Hart was suggesting. Oil is refined, and data, it can be quite expensive to refine it. The first thing about standards is you need to apply them before you're extracting the oil, before you're actually putting the data in. And that's really important and never to be forgotten. So the utility of standards, we're seeing a lot with data sharing initiatives. Project DataSphere, for one, is finding a lot of, they're mining through oncology data and getting a lot of new findings within that aggregated data sets. And most of that data is already within CDISC standards, using sort of SAS as a back end for that. You've also got alltrials.net, which is looking at aggregating all of the clinical trial data, most of that registry data. But there's big problems with that as well, and I'll come and talk about the reality of that and the utility of that data. Etrix, for one, is doing a data catalog for IMI. IMI were probably going down the same path of having a lot of data that was distributed and not brought together in one place. So the data catalog is another way of making sure that there's somewhere to see top-down what data is available, and then you can then do the aggregation of that data if you know where to find it. So a lot of talk about the future, and I've got one slide coming up about real-world evidence and virtual trials and data aggregation. I mean, trials are very expensive. There's a lot of risks. There is a lot of existing data out there. Sometimes you could aggregate all of that data and maybe not actually hold the trial to find what you need to then move on to a more specific trial. Looking at examples, the infectious disease research and the mistakes at the clinical, the interchange in London, the CDISC Cafe conference, 3 a year all over the globe, and the one in Europe. Dr. Laura Merson from the infectious disease data observatory talked about the mistakes they've made. And we all know about Ebola. It was too quick, too slow to react. The data was all in a hodgepodge of different formats, and no standardized eCRF was used in the first few months. CDISC developed one as quickly as possible, and that did help with some of the data aggregation, but there wasn't actually a real data standard for the patient data itself, just for collecting the data up front. So the learnings coming out of the amount of data they could have had there was a wasted opportunity, but things such as you look at malaria right now, that data is being aggregated much more successfully. The same with Zika, and CDISC has been very involved in doing CRFs for Zika and looking at using things like the malaria standard we developed for the IDDO and using that for Zika to get up and running quickly and get the utility from the data. So we had a very nice presentation from Dr. Laura Mercer, and I've got a slide on some of the realities on that. But just going back a step, and I think it's important to think about the preclinical data. While this guy's, due to politics, fallen off the landscape of the FDA, to the regret of many people in the FDA, he had some good ideas, and he was an advocate for data, for standards, and that's Dr. Rob Califf. So we'd held a summit with Dr. Rob Califf and CDISC and other people in data standards, and we'd sort of defined a real way forward to make sure that we were getting the best value from our standards and people were pulling together. So he did a lot before he did leave. But one of his ideas was to build a database for clinical research, but preclinical data. And I think it's really important to look at preclinical data. We have a standard called SEND, which people are implementing, but the amount of utility you can get from sharing that preclinical data, if it's pre-competitive, is huge. There's this study here, Glenn Begley talked about 53 landmark studies, mostly sort of oncology, mouse experiments. 47 of those could not be replicated, and they tried several times. Were they using standards? We're talking preclinical, so at that point, SEND wasn't mandated by CDISC, so actually, probably not. And that was a lot of the problems. But beyond that, it's the control vocabularies being used, they're not always available. And we're now extending SEND to look at CMC data, and we're also looking at SEND to integrate with something called IDMP, which I mentioned, which is how to identify a substance, to make sure that people aren't entering a substance which would be called 12 different things all over the world, various trade names. So that information can be mined, and it's much more semantically robust. And I think that's a real important thing for the future, for companies to be able to mine their preclinical data, even if they're not sharing it, to be using the right standards, the right control vocabulary. So, looking at mergers, you're talking and wiping the value of tens to millions, off their data if it's not in a usable format. So a lot of the lessons there about sharing toxicity data, and sharing mistakes about what fails up front. Why are people going down the same route someone's already trialed and failed in testing, when we're really trying to work in expediting drug development to save lives? And if it's not about humanitarian aspects, it should be about finance, if that's not enough to turn on pharma. So, we look at this in the press all the time. Why are drugs expensive? And it's not big bad pharma, as some like Ben Goldacre might always say, but it is the development, and you're talking sometimes well over $1 billion, maybe $2 billion for a drug to fight against cancer. But as I've said, if that preclinical data was already shared, all that preclinical research might not be necessary, and we could really expedite what we're doing and then keep the price down of those drugs. That would be really where we want to go. We don't want to be charging $180,000 for a treatment from AstraZeneca. They have to recuperate their costs, and there's a model that allows this to be sort of the only way at the moment. Just a little bit of an overview of the sort of information we've got put together for the repository here that the eTrigs guys have been working on for IMI, and that's all about using good data with data standards and adding in the metadata, and then the data sharing. It's usable because we've got those standards up front, and that's something that's going to give real value to IMI. Just want to go back to Ebola, and these are the sort of lessons that we're learning because we weren't ready, and we need to be ready. Zika is happening right now. It's crossed a horrific amount of borders. I can't remember how many countries. We're talking, it's really a global disease, and it's many countries. It's shocking to see how quickly it's moving. And we don't have a data stand. We have some CRFs already now for this research. So again, similar mistakes are being made. The sort of lives lost in Ebola, we don't need to read the figures there, but I think it is a very real thing. We've heard many doctors talk about it at some of the CDISC conferences, and they've been in the thick of it. They're exposed to this risk daily and doing their job against these incredible odds. And I think the data standards, they totally understand, and we're working very closely with these clinicians to make sure that we can try and supply them with the data standard sooner rather than later to save these lives, and to make sure that we can use this data even if we don't fix the disease during the epidemic, that later we can use that data so we're ready next time. So convergence and advancement, moving towards semantic interoperability. Well, we have to start somewhere. As I said, it's a lofty word. Controlled terminology. I mean, it's a pretty unsexy concept, but it's the nuts and bolts of what's within a data standard. Yeah, we don't want people just willy-nilly entering things by hand. We don't want any human error. We want useful codes. And looking at this as our rocket fuel, this is Professor Joseph Ayertz from Vienna University, who helps see this with a lot of coding and a lot of the strategy around some of our technical standards. And he's in agreement. We've got Dr. Laura Becknell here today as well, that we need to get our coding for our terminologies consistent. And he's talked a little bit about, we don't need to reinvent the wheel. And the typical thing with standards is to adopt, develop, rather than go out there and do it yourself, and to make the best of what exists. And he's talking about using and converging a lot of these controlled vocabularies. We all know that SNOMED and MEDRA don't do exactly the same thing, but if they work together, they could save a lot of resources and make things a little bit easier for people. And so CDIS know that there's a better way of doing controlled vocabulary within our organisation. So I've got a few slides on how that works. I'm just going to go forward because these are a little bit out of line. I'll talk about this one first. So biomedical concepts, I'm sure many of you have heard about this in the past. And this just cleanly shows three types of data. The zenith at the end there with the light bulb on is where I'm going to finish. But at the moment, reality, hopefully most people in the room are moving towards somewhere in the middle and towards the end already. But biomedical concepts will allow this to happen with a much, much lower bandwidth of effort. So looking at the standard distributed data, and you have obviously the various types. You've got your animal data, human phenotype data, and then you have your clinical data as well, and all the rest of it. Looking at aggregated data, there's a lot of relationships that will not exist because of the lack of interoperability within that data. So there's loads of learnings that you can have from integrating that data properly, the phenotype information, and the inferences that can be made from some of the disease paths and the knowledge around those phenotypes with that clinical data to find a shortcut. And even the design of the clinical trial itself could be much more focused. And this is what we're talking about with precision medicine. So looking at linked data, I'm going to go back now just to those slides there and drive forward. This is really what CDIS standards look like, sort of a tabular format. We have codes that the database allows you to search on, but it is a table format, and that's very, very limited. This is sort of the idea of this biomedical concept. You're looking at the relationships between various elements. Someone will map out the disease path. This one here is modeling in microarrays. And it's something we did for our pharmacogenomic standard. So from this, then, everything is then put into machine code and into relationships. So we have an electronic version of that standard. But also this is for the clinician to understand the relationships, and they'll agree these with us within a team, and then we know that we've modeled this right. This will all be mapped to the bridge model, which that's biomedical concepts that are all mapped in various domains of healthcare, and that's a real nice underlying way of making sure that everyone is doing the same thing and everyone's on the same page. So why does it matter? I mean, most studies fail. That's the cost of the drug. It's not just the one success, it's the ones that have failed before that actual drug has worked. Looking over here, the success rate of using sort of genotypic information can often double the success rate and probably beyond. So it is worth taking that extra step, of course. And these are the sort of information you've got available to us, and that should be used within the study. And through the middle, you've got sort of the CDISC standards. We're now moving into the genomic standard to have that summary information as well, from the mouse model, from the genomics as well. So putting it all together, it's a great advantage. So graph databases, if you haven't heard, really are sort of an expression of those business, those biomedical concepts. You'll see here we have a standard intrinsic model. You've got tables within our standards that link to other tables, but you've got many, many tables and many relationships. So it's a mess. Things are lost. Once you start looking at a database, you have to know what questions to ask. Otherwise, you're never going to find the answers. With a graph database, and I'll move to it now, I think, it's probably not the best version. There's a simpler version here. But just looking at medical history, and this is the aggregated graph database. Looking at it this way, you can see where there's large relationships, and immediately you get this helicopter view, and it's obviously it's now 3 dimensions on that 2-dimensional data. When you start talking about the metadata, you've really got those 4 dimensions as well once you start to drill into this. So it's a much more intelligent way of our standards to be expressed. I mean, we're not talking about moving away from a written user guide, but we are talking about the implementation of these biomedical concepts probably being used something like this, so those relationships and the things that they infer become evident. So this is medical history, one example here. All the roads leading to Alzheimer's disease, ignoring the sort of noise on the outside with the other sort of typical effects of the drug, headache, etc. So the idea of graph databases is ideal to store complex clinical data. Terminology is more important than structure. Again, let's have our terminology right, and those relationships will then aid this whole sort of representation. And the existing data really is just the best way to model those concepts. This one here, this is sort of moving towards registration of clinical trial standards. And the first thing we want to do is see this with IDMP. And we're looking at doing that this year. So that's all the substance information, if you follow this path along here, all the way down through INCHI files, and then you've got components of drugs. Well, that falls back into a standard done by the FDA and the EMA some time ago, a project that I was running then, but that's 1123. That defines how a substance and all the component parts of it need to be defined, and also the control vocabularies for those substances. If you look at the clinical trial registries right now, you type in a substance, you have to spell it exactly right, but you have to hope the people that enter that information spelled it in the same way. You have to hope that they actually call it the same thing. And you look at that information, it's a travesty. It is. And a lot of people have been through clinicaltrials.gov and so on and so forth, and they just can't aggregate that data to find out what studies have been done on what drug, at what dose, what strength, so on and so forth. And it's incredibly important. The target, all this information, the drug target, protein database, we can pull all this into one XML message that farmers should be able to push out to those registries, saving money, the redundancy of loads of people doing this on various different sites with the same sort of trial. Again, it's just replication, but it's also a lot of human error. So we're trying to build this standard. It might take us a few years. People are arguing how long it's going to take, how complicated it is to have an implementable protocol. And they're all very valid arguments. It's going to be quite complicated, but we already have a CTR2 version, a CTR version 1 that's been implemented in Japan. And so the Japanese, again, ahead of the curve, and they've done a great job of implementing that. So it's a WHO registered database, so they're going to be giving much better quality than a lot of the other registries in the next year once they finish that. So that's sort of a look into the future. We talked about big data. Now this comes from Dr. Hans-Jörg Eichler, who presented again at the conference 2 weeks ago in London. And a lot of people think there's a lot of hope, and there's obviously the IMI project. This is where he borrowed the slide from. A lot of people think there's real potential here. There's others in the room, I won't mention any names, but way over there did challenge Dr. Eichler and said, what about all the noise? And this is really a good way of aiding maybe signal detection for post-marketing drugs that are out there, to see really are they giving the sort of effects they were designed for. With precision medicine, we would hope so, but there's not a lot of precision medicine going on right now. So I think it is valid. And you see here, this is quite clever, that just the sight of the little emoticons, people can probably aggregate these sort of emoticons. Again, there's no control vocabulary, so you've got some difficulties, but the brand name, the dizziness, the effects of these drugs, the time, and they have all measure codes for these sorts of things. So there's a nice way of doing an algorithm to try and get some information out of this. And I think a lot of lessons the farmer can be taking about how their drugs are doing in the real world, and hopefully a lot of it is going on through IMI already. So just last couple of slides. I've talked about what CDISC is sort of doing here and the sort of technologies we're moving towards, which will be really great news for a lot of the pharma companies and other partners in the room. Our move towards an ODM2 I talked about with JSON, RDF, and RESTful web services for our shared metadata repository, and you'll see in the training that we're going to do here, showing you the reality of what's available now, what is coming. The enrichment of these biomedical concepts, and we're working with EBI, always working with the National Cancer Institute. Prioritise community requests is something as well. Community work is really incredibly important because we're only about 40 people that see this, but we're well over 1,000 and counting when you talk about all our technical teams and our volunteers. So beyond 10 years, well, I didn't have long to do this slide, but there's some of the obvious things here is wider collaboration to build and merge terminologies. Let's get rid of the waste and the confusion over what terminology to use. Prevalent open technologies for metadata entry. We have some overhead for share. It's not always going to be free, but hopefully moving forward, as we increase our membership revenues, we can put these things out there as open source. Shared global repository for business concepts, and this is about working with scientific communities to define these business concepts and move as quickly as possible. Deprecation of duplicative control terminologies is similar to the top one there, but especially transport mechanisms as well. There's competing transport mechanisms. The FUSE group is already doing a paper on that to work with the FDA to try and replace the SAS transport mechanism. But there's a lot of competing future for this, so that needs sorting out. Talk of artificial intelligence, again, I think it's a very big word, and it's far off, but and some of this can be used, I think, in the future. But I think probably for some of the questions, there's probably a few people who are more qualified than I to give their vision on how this could happen in the future and how we can really speed these things up. Good. Okay. Thank you very much.
Thank you, Paul, for a talk about a topic that is sometimes pretty hard to digest. Any questions for Paul?
Hi, Chris Marshall from Biosci Consulting. A couple of people today have mentioned the oil industry already.
Yeah.
The oil industry got its standards sorted out 15 years ago. Why is it taking so long in our industry?
Yeah. The oil industry, the insurance industry, and the banking industry, that's true. I mean, all these industries are well regulated, but I think this is a very complicated industry. I think it takes a little longer to implement. I think the regulatory boards are giving a little bit too much leeway in terms of when these things have to be mandated. And you can see that consistently as we bring out new standards. It's normally looking at pharma to implement them and do the best job they can, because the regulatory boards are sort of lagging a little bit behind with their own systems, and their own systems are catching up nicely now. So I think in the future, we should all be moving forward. I think that might be 10 years before metadata registries see this, designing now will be implemented globally, and everyone's on the same page, and it happens at the flick of a button. But I think that should be more of a future statement for the next 10 years. It's a valid question. I don't know if other people have other inputs on that.
Oh yeah, okay.
I'm going to get help from Laura now.
Hi Paul, this is Adriano from the University of Luxembourg. Thanks for the talk. I could follow recently in the scientific publication that the NIH funded projects in the US, they are promoting even more new projects to receive funding only if they share the data, the clinical research. And in the FDA, you've got the suggestion to upload your data and annotate it in a CDISC compatible format, let's say STTM, for example. When do you think these two streams will match, that you have to share your data and annotate it in CDISC?
Yeah, I mean, it's interesting, and I mean, Laura will go into it as well, but when I started, I left from the EMA, and I was involved in data transparency there, and the EMA were great advocates of data transparency, but do you want me to get into the politics now about how they got quashed and there was an ombudsman to try and move that forward? And it's still being fought because it comes down to commercial confidential information and the billions of pounds that pharma are putting in, and the reality of you can only share certain amounts of data. So I think preclinical is a great start. I think it's a conversation that can take a lot of time. There's a lot of people in the room, definitely from pharma qualified, to say, you look at GSK, they come up top on data sharing all the time. Some pharma going with it, see the advantages in terms of PR, some are struggling for one reason or another. So I don't know, Lauren, something close to your heart, what do you think? Sorry, I get a microphone there.
So I think to the question that was asked first, and maybe also kind of piggybacking off of what Adriano said, in the US, in this particular case that Adriano mentioned, there is now this push by the NIH to require academics to have a data sharing plan in all grants, not just grants that are quite large, over $500,000. At the shift, obviously, there's requirement from FDA for CDISC submissions. However, I am an academic, and I can tell you that as an academic, I know that what I put in my data sharing plan may not matter. There is no teeth behind that requirement, and it's something that our colleagues at the NIH are very well aware of. They're looking at how to properly incentivize academic researchers to help push forward innovation, not stifle things, but also to ensure that there's proper value from taxpayer-funded initiatives. So I think really we need to look at not just regulation, but in this space where such a bulk of innovative research is happening in academic centers which don't have business drivers in the same way that industry does, we've got to look at appropriate incentives, and that's a global issue.
Yeah, it's a great point. And I think the clinical trials generally, it was worked out. There was a presentation at a meeting I ran the other week, and ex-FDA staff talking about if everyone was to be fined for how late they are on disclosing their clinical trial information, it's way over £1 billion that the government of America haven't pulled in. And it's been mandated, it's been stated that there is a fine of $10,000 for each day you're late on putting that data in, but so far no one's been fined. So that's the point in case, I think.
All right, any other questions? Not quite ready to go to, I have. I mean, it just came up, the whole issue, if you look at the adoption of CDISC, it's basically pharma right now. And if I look at the enormous machinery that pharma has running inside to keep that system up, it's completely understandable that that is not spreading widely, for one. And with the FDA requiring it, that's basically the incentive. And nobody likes the knife to the throat, right? That's the only incentive. So there has to be something quite different that needs to happen to really make it work. And it's an incredibly complex semantic environment, this whole biomedical space. So is there a question, and I don't think we can answer that now, but just want to put it out as a question. Is there a question if we should rethink the entire approach to how we do that? Right now we try to get rid of all the fuzziness, we do all this disambiguation, we try to pin it all down. That is not the nature of human communication, and that is not what this enormous complexity of the environment really lends itself to. Right? We're running the risk that we spend all our energy in trying to sort this out to the last detail and create something that doesn't have the incentives to actually adopt it.
No, I think
we need to much more fundamentally rethink that whole thing.
I think there could be a flexible implementation of CDISC, and I don't want to speak out of turn, so I'm now saying I'll talk from my own personal interpretation. We've always worked with academics, and we work with them a lot more day in, day out now, and many have joined as members like Oxford and Luxembourg have, Imperial, we're working very closely with. And I think a lightweight version of CDISC, and I think we can move forward with that with the metadata registries to provide them with these templates. And we've talked about templates a lot with eTrends and a lot of the CEDAR project that's running. So I think there should be something lightweight that is implementable, that isn't a barrier to them getting better data quality. And I think that's pretty achievable. I don't know, Lauren, if we've got experience of doing this, but I think there is a way. And ODM is that way of getting a lot of value from your data, and using the CDISC terminologies without using the whole cloud of CDISC standards. So but I don't know if we've prescribed a way, and we've had time to prescribe a way that can be followed and implemented easily, but we certainly advise people that you could, yeah?
Yeah, we will. That's the direction
Yeah.
that we're wanting to go in. We're wanting to have our standards not just be computable, but also ontologic representations of what have historically been 2D tables, that's useful in some senses, but not in others. No worries. I think finding that point where you have appropriate levels of semantics so you can meaningfully exchange information, finding where there's a balance between everyone absolutely knowing exactly what we mean to the ability to make inferences where relationships are in existence is something that we within CDISC are really pushing towards. So it's about finding that, what you might call a sweet spot, Michael.
Perhaps this is an extension of what we've been discussing, but also perhaps relevant for this evening's keynote discussion. But what degree do you think that the resistance to use standards is really linked to also resistance to share data or uncertainty about the value of sharing data? Lisa, that may be a tough. I don't know if you want to answer it or Paul. Because
Chicken and egg, a little chicken and egg.
I think there's a link there.
Yeah, I think so.
And it may even be, well, okay, I can use standards, but I don't know if I really want to be able to share my data later. So why would I put the energy into making the standards? And I think this is something we encountered in Matrix when we talked to projects.
Yeah.
If you said the words open data to some projects, they sort of shut down. And so that really, and that's sort of the inspiration for this afternoon session as well.
I just want to make a comment of your question. I think, my personal view is the resistance of using standards coming from the researcher, because they have to do actual work. The resistance of sharing data is from PI, because they don't want to share the data.
Yeah, that's a good point, because there's different stakeholders.
Well, okay, we're getting closer to lunch. Last chance for questions. So everybody's hungry. All right, so I want to thank all the speakers. I want to thank the organizers. I think it was a nice